Here we go, we have a question rotate by 90 degree, and we have a matrix of n cross n size. We have to rotate it by 90 degrees in anti-clockwise direction. So we got this array. So the answer will be this. So let me give you a visualization. So if I got this array, so the array is rotated by 90 degree in anti-clockwise direction. So we got this 369258. So we got 369258 and 147. So that's how it will work. Then for this, the answer is this. So the question is pretty straightforward. Now let's try to build the approach. To solve this question, we have two approaches. First is to take four variables, this variable, this variable, this variable, and this variable. So now let's first focus on the approach 1. So in this approach, we have four variables assigned to these values. So we will swap the values. The three will be here, then 1 will be here, 7 will be here, and 9 will be here. Then we have to move. So now its next value is this, its next value is this, 9 next value is this, 7 next value is this. So then we rotate these values. So 2 will be here, 4 will be here, 8 is here, and then 6 will be here. Then the next value is, after 2 we got 3, then we have traversed till 6, then next value is this, then this, then this, but this value is already shifted, but so we don't have to again shift this. Next is time to go inside. So we have talked about this these cells. So let me give you an example of this. So we have traversed in these cells, so then we will go inside, then we try to reverse all the cells, all the elements inside of this matrix, inside of this box. So we will rotate it. Now let me show. So let's build an approach. So what we have to do, for 3, for length odd, in this case we have 3, so 3 by 2, because we are reversing the values, so and we are going inside, so the length is shortened. So for 3 we got 1, so we need to only do the step for 1. Then we have this 4 by 2 is 2, so we have to do two rotations, one for this and one for this cell, one for the inside cell. So the resultant will be the rotated array. Then what's the loop and how do we pick the element? First we have this element. So let me talk about this. So we are starting with this is the element ij. So we got I and j. Initially I is 0 and j is dependent on I. How? If I talked about this, we have this cell. So in this I is here, then j is also start from this cell. So j is initially also starts from I. J is dependent on I. So I is 0 initially. Initially I is 0 and j starts from I. Then what's the boundary of I? What's the boundary for I? For this 3 by 2 is 1. So we are only doing this for this. But for this we got 4. 4 by 2 is 2. So we are doing this for this time, for this time. So what we'll do is, if I is less than, so we got n by 2, and it is lower bound. Lower bound. Then what's the length for j? J starts from I itself and go till. For this we are traversing for only 3 elements. We will pick these 3 elements, we will pick these 3 elements, then we will pick these 3 elements. Then if we are inside of this, we are only picking one element. So for this we are not going till this cell, so it is n minus 1th cell and n minus 1th. Then for this we are inside of this, and in this our I is 1. So n minus 1, which is this cell, n minus 1 is this cell, then we are not going till this cell, we are not going till 7. So we can write it like this: n minus 1 minus I, and this thing n minus 1 minus I, we are taking lower bound. So initially n minus 1 is the last cell, and n minus 1 I is initially 0. I is initially 0. So n minus 1 is this. So we are not traversing till this, we are only traversing for 3 elements. Then we got these 3 cells. So now let's try to reverse the elements. First we got this element. So this is the I and j element. So let me write it like here, right here. So this is I and j element. So then we are increasing our jth, j will increment. Then we got 2, then we got 3. So we have traversed till here. Okay, we have to traverse in this way also. So what is this? This is the our column. Column is column is fixed. Row is changing, and initially we got n minus 1 minus ith, because if we talk about this, we are traversing in this way, then we are traversing in this way. So n minus 1 is for the last column, then for the last column, and we are also traversing inside of this box. So for box we have to write it like minus I. So we got this, and initially our j, the column is constant. So column, in this case column is this, so column is dependent on I. So first index is this, row is this, and column is dependent on I. So this will work, and I think I have made a mistake. So here we go to j, we go to j n minus 1 minus j. So in this j is changing. So first we got this, then we got this, then we got this. Then we have traversed for this. Now let's talk about this. So we are traversing for 3 elements. So this is the uh, last row column. Then we got last row, but the column is changing. In this last row, but column is changing. And in this is not a last row. This is second last row. So our row is fixed, but is also row is fixed, but it is also dependent. It is also dependent on I. So we go to this, and for column is constant, but is also dependent on jth. So we have traversed in this way. So now let's talk about this. What is this? This is the last row, but uh, now column is constant, but row is changing. Column is initially the last column, and row is also last row. So last row n minus 1. Our row is last row, but row is changing, and row is dependent on j. Then for column is initially this, but for this we have to traverse in this way. For the inside cell, inside the box, we have to traverse in the upside direction. So we go to this is our last row. So we have talked about row, but for column, this is the first column, then this is the 0th column, then this is the first column. So column is dependent on I. I think I have made a mistake. So this is this and this is this and this is equal. So we have to traverse in this way. So first we got this. So in this we have this row, then we got this row, then we got this row. So our row is changing. So row is dependent on j. Then what about column? So let me erase this. Then what about column? So column is initially the last column, but column is also dependent on I. Column is the last column. So let me write it here. Column is the last column, but is also dependent on I. So we got this. Then we have traversed in all four directions. For this cell, the element for this cell will be the 4. 4 will be here. Next for 4, instead of 4, the value will be 3. So for this, the value will be this. For this, the value will be this. And for this, the value will be this. And for this cell, the value will be the first value, which is 1, but we have updated it, so we have to store it. So let me show you the code. So we got this our I loop, then this is the jth loop. We first finding our initial element, then for initial element we are updating our element with this cell. Then for this cell, as I've shown you, for this cell, and next for this cell, as we have updated our I and jth, so we have to store in a temporary variable, so we can then update this cell. Let's submit this. Now let's talk about time and space complexity. First, the initial for loop is n by 2. Next, it is dependent, but the worst case it will be n minus 1. So we can say it is n square or less than n square. So let's talk about the second approach. Second approach, time complexity is similar. We have taken this test case. So let's take this test case. 1 2 3 4 5 6 7 8. 1 2 7 3, then 2 4 9 8. So let's talk about this test case. And interestingly, this approach is pretty easy as compared to previous approach, as we have to think in I and j, but this is very easy. So first let's transpose this. The first step is to transpose the matrix. So we got 1, then 2, then 3, then 4, and 5 will be here, 1 will be here, 2 will be here. For 6, 7 is here, 8 is here, 2 is here, 4 is here. For 7, 3 is here, 9 is here, and 8 is here. Now we have to like rotate it in anti-clockwise direction. Rotate in anti-clockwise direction. So for this matrix, what's the answer? The answer is 4 will be here. So 4 will be here. Then we got 8, then 3, then 8. Then we here we got 1 2 3. So that's how the answer will look like. So as you have rotated the matrix, as you have transposed the matrix, so the answer is present in a reverse order. So we just have to reverse the rows. So just reverse the rows. So we got 4 8. So first let me write this 3 8, then 3 7 7 9. So then we got 2 6 2 4 1 5 1 2. So this is the rotation in anti-clockwise direction. So you can verify it, but this is the answer. So now let's build the approach. For transpose, we are starting with this index. I and j is same. Next we are transpose with this index. So in this, our I is 1, but j is dependent on I. J is dependent on I. If we are starting from this, just update the value. Then for this and this value, just swap the values. For this and this value, just swap the values. So initially I is 0, j is equal to I. Then j will iterate till n. For 6, well, for 6 we need to iterate till the last element, so we can reverse the elements. So we can reverse the elements. So it's for transpose. For reverse, we just need to reverse half the rows with the uh, downward rows. So reversing the rows, after reversing the rows, we have our expected output. So 1 will be reversed with 4, 5 will be swapped with 8, 1 with 3 and 2 with 8. We need to just iterate till here. What about even case? So we have this case, let's suppose. For this, just need to update, for this and this. If we will do with this swapped row will be to himself, but that will make no sense. You can like swap the elements, but the answer is same. So we just for 3 by 2 is 1. So just to take the lower bound, actually if we are starting from, if we are starting from uh, 0, so this is the excluding. So this is excluding, means 3 by 2 is excluding. So 1 till 1. So we just need to do the loop only once. So now let me show you the code. We got n, then we got this. We are like traversing, just swap the values. Next is we have rows. This I is for rows, then j is for column, then just reverse the rows. So we are reversing the rows and half the rows will be reversed. So that's the overall approach. So let's submit this. Now let's talk about time and space complexity. In this code, the time complexity is n square and space is constant, and both the code is provided in the description box. I hope you have learned something new. Give this video a thumbs up and subscribe to this channel. Thank you all for watching.